Hello Year 9. Today we are looking at osmosis in plants, and specifically I'm going to look at potato, although if you want to try this at home you could use sweet potato, carrot or beetroot. Be careful if you're using the beetroot because all the juice from it can stain your fingers and worktops. So if you wanted to have a go at home, I'd try potato, sweet potato or carrot. Now we already know that osmosis is the movement of water, and it moves from a dilute solution, so somewhere where there's lots of water and not a lot of dissolved substances, which is what we call solutes, to a more concentrated solution where there is less water and more solute in the same volume. We are using a sodium chloride solution today. The sodium chloride is dissolved in water, so it could have the little symbol AQ to tell you it's dissolved in water. Now this practical takes at least 20 minutes to work, so I have actually had a little Blue Peter moment and prepared some earlier. So I have got potato here in plain water. I have got potato here that is in a 0.5 molar sodium chloride solution. I will provide the instructions for making these separately, so if you want to have a go at home you can do. And finally I have got potato that is inside a 1 molar sodium chloride solution. Now for all of these we know there'll be salt water inside the potato cells, and there's plain water outside, or water that may contain salt inside the cells. There's either plain water or water with salt outside. And if we see a change in mass of the potato, that will show that there has been a movement of water from one direction or the other. If the potato increases in mass, we know that water has moved from outside the potato to inside it. If the potato stays the same, there's been no overall movement of water, although individual water molecules may have moved. If the potato was to lose weight, have a reduction in mass, then we would know that water has gone from the potato to the solution outside it. Now all of these potatoes were weighed before they went into the solution, and I've already had a look at the first one just to make sure I'm not doing this too soon. So the potato that was in ordinary water started off weighing 2.19 grams, so just make that a bit bigger for you to see, and at the end it weighed 2.23 grams, which is an increase of 0.4 grams. I'm going to ask you just pause the video now and calculate the percentage change. Remember, the percentage change is found by having the change in mass divided by the starting weight, and then to make a percentage you multiply it by 100, and the number will be between 0 and 100. If it is more than 100, you have gone wrong, because you're not going to have a more than 100% change, because percentage means out of 100. So the next one, I'll show you taking the measurements now. We've got sodium chloride solution, half a mole in there. Potato piece here started off weighing having a mass of 1.84 grams. To take it out, I'm using a spoon to take it out so that I don't damage it. I'll put it onto a piece of paper to absorb any loose water that has come out with it. It's not part of the mass of the potato. The balance that I'm using, which came from school, thank you very much to our lovely technicians, keep us going even in lockdown, has got a piece of paper towel on it that I'll put this onto so that we don't drip any water onto it. I'm making sure it's 0 before we start. And here we go. This potato piece now weighs 1.72 grams. It weighed 1.84 grams at the beginning, it weighs 1.72 grams now. So very easy to do our change there. And it's 0.12 grams, and it's a decrease. So it has lost water. Water has gone from the potato into the water outside. Now we're going to look at the final one, which is the 1 molar solution. Now we know already that the water showed an increase in mass, so water went from the plain water into the potato. 0.5 molar sodium chloride the potato had a decrease in mass, so water went out from the potato into the solution. So when you get to this bit, before you see me work out the measurements, pause the video please and make a prediction about what the result will be. Okay, let's see if your predictions were correct, Year 9. So, here comes the potato strip. Watch it, we're going to dry it again. Okay, we're going to get another piece of paper onto the balance. We're going to bring the balance here where you can see it, switch it on. Hello balance. It should zero any second now. Put the potato strip on. You'll notice I'm not touching it, I'm not squeezing it because I don't want to affect the amount of water. And that has gone down to 1.86 grams. Now this potato chip was a bit bigger and that means it has gone out. So I'm going to change that. If you're not sure about doing this without a calculator, I'll show you. 40, that's 8. And it's 0.18 grams reduction. Now, as I said, you will need to work out the percentage changes for all of these to be able to compare them fairly, because you can see the potatoes all started off as different weights, so the percentage change is the way to compare them fairly. So reminder over here that you need to have your change in mass divided by your starting. Just realised I'm writing that way, you can't see it. Okay, you have your change in mass divided by your starting mass. That line means you divide and then you multiply it by 100 to get a percentage. Now, where the numbers have gone down, that shows that water has flowed from the potato into the solution. So if we go back to our little notes we made at the beginning, water goes from something more dilute to more concentrated. So it's gone into the solution. That must be more concentrated than the solution inside the potato. So inside a potato, that has gone from the potatoes to the solution. So inside the potato is less than 1 molar solution. Over here, the 0.5 molar solution, we have got a change again, smaller change. Haven't got the percentage change, you're going to work that out at home. But again, we have had water moving from the potato into the sodium chloride. So that means that the concentration within the potato is less than 0.5 molar. So somewhere around here, there will be the actual molarity of sodium chloride that is equal to the molarity that is in the potato. And at this point, if you put potato into that level of molarity, you would not have a change in mass in the potato. Individual molecules in water might be moving in and out, but overall there would not be a change. Now there is a follow-up sheet to help you work through this, and there's questions. So I'm going to just quickly stop there, guys. See if I can turn the camera around. Okay, and